Good morning and welcome to the Axon webinar series. Today we have Jeffery Tang to talk about how to create customized command waveforms using pCLAMP software. My name is Jeffrey Weber and I'm the Product Manager for Electrophysiology at Molecular Devices. I'm very excited to introduce my colleague, Dr. Jeffery Tang from Molecular Devices. Dr. Tang will be highlighting using pCLAMP to create customized command waveforms, and then we will open up the floor for questions and answers. And now let me jump in with an introduction to our speaker, Dr. Jeffery Tang, Senior Application Scientist at Molecular Devices. Jeffery has over 10 years of experience working with Axon instruments. He has been pivotal in various product breakthroughs and improvements, including development of hum silencer technology and pCLAMP software upgrades. Jeffery received his PhD degree in molecular physiology and biophysics from Vanderbilt University and held postdoc positions at UC Berkeley and UCSF. His research interests include investigating modulation of calcium channels by metabotropic glutamate receptors. Now I'll turn it over to Jeffery.
All right. Thank you for introduction of the Jeffery Weber. And now let us start our today's presentation. So let me get this presentation mode. All right. So the title of my talk, as Jeff Weber already mentioned, that how to create customized command waveform using pCLAMP software. Now here's my agenda. So I will introduce features that help create customized command waveform, and I will perform the demonstration, the live demonstration using Clampex. Now, there are some default command waveform that in the edit protocol in pCLAMP, that under each epoch in here, that you will see a list of the default waveform that you can select, that you can use. Now, for example, if you use a step, that you have this step waveform, and you can use for the ramp, and also you can choose post train. And how about biphasic chain, triangle chain, and cosine chain? Don't ask me why it's cosine or sine, okay? Now, could we create customized command waveform using pCLAMP software? Now, how about customized waveforms such as theta burst stimulation? Now, in this theta burst stimulation is a quite typical stimulation, for example, people doing induced for the LTP, LTD, long-term potentiation or long-term depression. Now, in this particular stimulation protocol, it have 3 chains. Now, each, the inter-train interval is 20 seconds. You can see here 20 seconds. Now, in each train, there are 10 epochs. 10 epochs. Now, the inter-epoch interval is 200 milliseconds. Now, we have 10 epochs delivered at 5 hertz. Now, in each epoch, we have 4 pulses delivered at 100 hertz. Now, I would like to use this slide to show you. Now, this is a 3-chain and have 3 chain and delivered at 0.005 hertz. That means the inter-train interval is 20 seconds. Now, in each chain, there is 10 epochs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, delivered at 5 hertz. That means the inter-epoch interval is 200 milliseconds. Now, in each epoch, there is 4 pulses delivered at 100 hertz. That means the interpulse intervals is 10 milliseconds. Now, I'm going to show you later how to create this customized command waveform. Now, how about the other waveform, just like action potential? Now, I record action potential from this cell, and I want to give the same command to the same cell. how we can do it. Then we show you how about the sine wave. I show you the cosine wave. Now I show you the sine wave right now. And how about some, Chirp wave? Now come back to the same question. Could we create customized waveform? The answer is yes. Now this slide just show you some key features that found in Clampex 10. Now today I used the pCLAMP 10.7. Now there's a lot of this slide just lists many key features. Now the following features basically highlighted will help create a customized waveform, such as user list, sequencing keys, stimulus file, and digital bit pattern. Now today I just focused two, user list and stimulus file. Now let's just start with the user list first. Now user list can provide a way of customizing one of the range of analog output or digital output. Now it will override the general settings made elsewhere in the protocol editor. Now with the user list, you can select one of the range of parameters, for example, like duration or the holding level, to configure on a sweep by sweep basis. Now this function allows you to set specific values for each sweep in a run. And you can also set a sequence of values and have this repeat. I just want to show you some example how we can change the Epoch's holding levels in the sweep basis. Now, for example, the sweep 1, I want the holding to minus 50 millivolt. Then second sweep, I jump to 64 and minus 23 and 101 and 29 millivolt in sweep basis. Now you can also make these changes as a repeat. For example, sweep 1 minus 20 millivolt, sweep 2 100 millivolt, and let it repeat. For many time is up to you. And now I want to show you some example. The example of how to change in Epoch's duration. The first sweep, 20 milliseconds. The second sweep, 45 milliseconds. Third sweep, 100 milliseconds. And the last sweep is 75 milliseconds. Like, again, you can customize your waveform in sweep basis. And again, you can make it as a repeat. 22, 75, 22 again, and 75. I think there's very good features for you to customize your waveform. Now, what other parameter you can change in the user list? Now you can see is in this slide, you can see that a lot of things that you can change. Like for example, digital bit patterns, train period, and also you can change, for example, number of posts in P-sweep train, and even like time between sweep starts. So basically, you need to play around with yourself. Now, where you can find the user list? User list is under the stimulus tab of the edit protocol. You can see here, check these boxes, and then you will see a list of parameters that you are able to change. Now, just show you an example how to change. Basically, it's very easy. When you select the parameter to change, so for example, the epoch level, you just type the number that you want to put it there. They just show it here. Just type the number here. Now, for the epoch duration, you just type, like 22 milliseconds, comma, 45, and comma 100, right? It's very easy. Now you will see here, customize the holding level for each sweep. I'm going to show you some, demonstration for that. This is just show you example of just changing the holding level, and it is for the holding duration for each sweep. Now let me do the demonstration first for the holding level, and then the change in duration, and after that, and I will use how to use the user list to change the pair pulse, to make the pair pulse stimulation. In this, you can change the interpulse interval. And then after that, we will go to the theta burst stimulation. All right? So let's do some demonstration. Now I go back to Clampex first. Now today, the version that I'm using is pCLAMP 10.7. Now right now, I just in a demo mode. Okay. Now what I want to show you is that I just bring out one of protocol. It is a default protocol here. Now you go to the waveform tab. Now what I show you is that this is the waveform tab under the edit protocol. Under each epoch that you can select, those default, waveform. Now today, like I said, I'm going to demonstrate you for the holding level. Now you can see here by default there is a series of this multi-step. You can see here there's a step here. Now I want to change the holding level for each sweep. Now I have 10 sweep here. Now I go to the stimulus. You check for the user list. Now you select the parameter that you want to change. Now epoch A level. Now you select it, then you list the parameter value. Now I want to be the first sweep. I can put, for example, 99 millivolt. Then I put minus 159, and I can put 35 and minus 111, and I can go back to 156, and then you can go back to minus 10. Then, for example, I can go back to 145. How about that? So I make 1, 2, 3, 4, 5, 6, 7 traces. Now, if you see the waveform here, you can see the value, was overridden by the list number that you put under the user list. All right. So when you click OK, now I just want to show you. Just run this protocol. Now you can see the sweep, as the holding level that you created under the user list. Now you can see here, as I mentioned, that since I only have 7 here, now I have 10 sweep. So the last 3 sweep is basically follow the 145, right? So let me show you one more time. Right. All right. So I show you how to change the holding level. Now let me show you another example how I can change the first duration. Right? So let me go back to here, that I can go to the epoch 8 duration. Now you can put any number here. Now I want to show you that because for the time there's no minus. I just delete the minus. Okay. This minus. All right. So I think we can do something here. Then look at the waveform tab. Now you see the duration is under the list. Now let it delete this one. Just put 0 here. All right. Then let's hit OK. Then you can run it. Right. Now I can show you one more time. That clear before each sweep. So basically, the holding level is based on the setting that you put it in the under stimulus user list, right? Okay. So that is the way that I want to show you how to change the epoch, duration. Now, how we can do for the a pair pulse, pair pulse facilitation. Now let me bring out I already created this protocol, right? Pair pulse protocol here. Now what you need to do is that go to the waveform tab. Now, so basically, I have 50 millisecond baseline. Then in order for you to see the pulse, I just give 100 millivolt here for 2 milliseconds. Now you can put, for example, this is 2 milliseconds. You can put 14.8. That means that the start of the second pulse is about 15 milliseconds apart. All right. So when you see here, you can see update preview, where you can see the pulses here. All right. Yep. Now, in order to change the pulse interval, now let's do something here first. Hit OK. Then you can see that it's 50 milliseconds apart. Okay. Now, I want to change this duration, right? That you can monitor the inter-pulse interval here. Let's say here I can change for the Epoch C. Now I put a number here, 50, 123, and 30. That is the inter-pulse interval. And I hit OK. That, let me show you this way, clear before each sweep. Then let us do it. Amazing. Are you excited? Yes, I am. Right. That's very fantastic, right? So you can monitor, the interpulse interval. Now, at least I want to show you one more time, right? Okay. Now let's go back to the next one is what I said, the theta burst stimulation, because you need to have the concept of the user list. Now, I just want to bring out your attention again. Now, I'm going to create 3 chains, and in the train's interval is 20 seconds. And in each train, I have, 10 epochs. And then the inter-epoch interval is 200 milliseconds. And in each epoch, I have 4 pulses delivered at 100 Hertz. Now, let me go back to the pCLAMP. I create this protocol, theta burst protocol. Now, in this protocol, is that, okay, the protocol. Now, first of all, I create the 4 pulses first. Now, in order to create a pulse, now here for this protocol is that I created, it is for the digital output, because theta burst stimulation protocol has been used to induce LTP, LTD in public LTP in hippocampus CA1 region. Right, so basically this is digital output to trigger the stimulator that stimulate the fiber. So in order to do that, so there's a pulse. So it's a train that you need to tie. So imagine here you have a BNC cable connect the digital output channel 0 to the stimulator. So you can see I can check this one digital output and 0, 0, and 0, and that is a status key here. Now this one is corresponding to the digital output channel 0. Now imagine that you have the BNC cable connection from digital output channel 0. Now this gives the train pulse, and I give 100 Hertz, 100 Hertz. And the pulse width, I give 1 millisecond. Now I give 34 milliseconds because I will see, only 4 pulses. Let's just give an example here. Update preview. Now I want you to see clearly that I just show you here. The 4 pulses. This is the digital output to send it the trigger to the stimulator. All right? All right. So that is the 4 pulses. Now, I want to use the user list. Okay, I want you guys to think big when you learn the user list. The thing big is that now I need to give 10 times, right? 10 times, right? So, and then in 10 times, that is 200 milliseconds. And then wait for 20 seconds and give another 10 epochs that I use this is user list. What I need to do is that change the time between sweep start. Now what I mean is that I want to monitor to hear the sweep. Okay, you go to stimulus, you select for the time between sweep start, then you put 0.2, that means 200 milliseconds, right? So you need type 1, 2, 3, 4, 5, type 9 time because it's in the epoch interval. Then at this one, I put 20 milliseconds here. So again, another 9, and put 20 milliseconds, another 9 for 0.2. Right, in this protocol, you are able to create this theta burst interval. Okay, now I just show you a quick demonstration. Okay, now we hit OK. Now you need to look at here. You will see it quickly. You have a, because the time 200 milliseconds is very short time. Okay, you will see here. I click here. You can see here right now is 10. You know, digital output send it out. Now wait for 20 seconds. Another will come here. Now look at here, 20 seconds. Yep, you see that? Right. This is another train, second train. Now you wait for another one because, like I said, this one I'm not connecting to the stimulator, so you won't see those, stimulation artifact. But by doing this, you can see here another 20 seconds. Now you can see another, 10 epochs is coming up from here. So by doing this, setting up like this protocol, user list, change the time between switch start, and then use this one to set for the pulse. And for each epoch, you have the 4 pulses. Right, then the start to start interval will be overridden. So yes, that is and again, you need to set up here is the sweep duration 31, and the sweep duration is 0.035 second here. All right. So I hope that you can play around yourself, that you should be able to figure out, the theta burst stimulation. Now let me get back to my presentation. Now, I mentioned about the user list. Now, how about the stimulus file? Okay. Now, stimulus file is one of the features that I like a lot, and I know that a lot of customers, they don't know how to use it. And basically, stimulus file can create your own waveform. Okay. For example, you can import the ABF file or ATF file, okay, from the data that you already have, for example, action potential. And also you can create your own waveform in the clamp fit, for example, the sine wave, and also for the chip wave. Okay. Now let me show you how to import the action potential waveform. First, we need to, to find the data that you want. For example, in this data, it's very good action potential. Then basically, you can find the stimulus file under the edit protocol, the analog waveform. You check this stimulus file and click this stimulus file to open to retrieve the import waveform. Now, for example, in this case, I choose action potential 1. Then after that, you see that the file will be shown from in here. Then again, you need to make sure that the strip duration is correct and at the same sampling rate. And also you might need to make sure that the holding level is correct. Now, after that, this is basically in the waveform preview, that the waveform preview, you can see the action potential waveform in here. Now, I'm going to show you how we can do it, okay, in Clampex. Now, like I said, first of all, you need to bring out the file that you want to import. Right, the file I want to import is called action potential 1. Now you can see here is very good, action potential waveform. Now, first thing you need to do is to go to the file property. Now, make sure that how many sample here is 102.0 milliseconds, 1020 samples. And then the sampling rate is 10 kilohertz, all right? And you can see here, the holding level is -70. So you go to the Clampex. Now I open a new protocol. Then you go to the waveform tab. Now check this is stimulus file. Click this button. Right. Select the one that you want to import and then hit OK. Now you will see the file will be imported, will show it here. Now to make sure that the strip duration is correct, remember that I show you is 0.0102, is 1020 sample. And then the sampling rate is 10 kilohertz. Then the holding level is -70 millivolt. Now, after you make sure that they're correct, then you go to the update preview. You can see, I want you to see more clearly that this is very beautiful here. Is it? Right. It is a action potential waveform that you can apply this waveform to the next cell or the current cell that you have. All right. So I show you the way now how to create, your own waveform. Now let's start with another challenge, right? Now how about the sine wave? Okay, sine wave. Now when you create a sine wave, the trick is that you need to know the formula, the expression, how to create a sine wave. Now, by linear sine waveform generation, well, you need to create this, know this expression. So this is the function for the sine wave. Now, A is the unit amplitude. What is the amplitude of this one, of the sine wave, and pi is 3.14, and K is the frequency in hertz. Now, for example, for creating a 5 hertz sine wave, that the function is that, the sine, emergent right now, I just put the 1 as a unit amplitude. Now, 2 times pi times phi, because K is the frequency is phi, so that the function is that Y, in terms of the function of sine, 10 times pi times x. Now, this is very important formula that you need to create it in the ClamFit. Now let's do the demonstration in ClamFit. Now let me close all first. Now the key is that you need to create your own waveform. Okay, now before I show you that the action potential is basically the data that you created from the previous, recording. Now I want to create a waveform. That first you can use the ClamFit. Okay, to do that. Now you can use any, sheet to do that. Now, the key is that go to under the analysis, you need to create the data, all right? So I want to create, first, I want to create a 20-second, how about that, 20-second. So 20-second 5 hertz sine wave. Now, in here, what you need to do is that you need to type 20, okay? Now, 20-second, you need to type 20, right? I would like to say it's 200,000. I mean, in order for you to have more sampling point, that you need to type, 200,000, okay? Now, let's go to the linear. The increment is, 0.0001. Now, when you do that, you will see here, it will show you in here, you view all the way to the bottom. That will be about, right, 20 seconds. All right, 20 seconds. Now, the key is that you need to create the sine wave. Now, go to the analysis, create the data. Now, you need to go to check these boxes. Now, the column already automatically go to the B, the same, the number of the sample. Now, in here, what you need to do is that you need to, you remember that this is the one that you need to put it here, is sine 10 pi x. So what you need to here is that this is supposed to be 10. Okay. Right. Now 20 I put here, give us a 20, that means it's a 20 volt, 20 millivolt. Okay. You can put the magnitude, okay, 20 millivolt, and then sine, and with 10 times pi times x. So that is basically is the expression. Now let's do this one first. I don't use 20, just use this one. Okay, make it easy. Okay, now I hit OK. Now, because we are going to in a sweep basis, okay, episodic stimulation. Now you need to copy this one, paste it to column C, and paste it to the column D, right, in order to make it as a sweep basis. Then you can save it as, okay, now we can save as, you can say 5 hertz sine for today. All right, for today. Hit OK. All right. So let me close off. Now you can open the data, ATF format, because it's created in the result sheet. Go to the ATF format. Now 5 hertz sine today. That you can open it. Now you can see very beautiful 5 hertz sine wave. Is it? Yeah, amazing here. Now, remember that in here we don't have the unit here. In order for you to put a unit, you need to save as. The save as, 5 hertz sine today is a ABF format. ABF format. Click save here. Now, again, you will see here is 5 hertz. Now, you can put the unit here, go to the edit, and then modify the signal parameter. Now you can put millivolt here. All right. You can, of course, you can put current for picoampere if that you want to inject the current. They can hit save. Now you can see here, it's a millivolt here. All right. Now what you need to do, now you create your own waveform right now. Then you go to Clampex, and then you have new particle, for example. Now you go to the waveform, you go to stimulus file, then you choose this one that, again, today, 5 kilohertz, 5 hertz sine wave, and hit OK. Now make sure that you have the same swift duration. Remember that, 20 seconds, all right? So when you hit update preview, now don't worry about that, because see, is it beautiful? Now let me show you one more time. Right, so it's a beautiful sine wave here, all right? So I show you, the way of how to create a sine wave. Now let me show you how to create another waveform. It's a Chirp waveform. Now again, it's very important is that you need to know the mathematical formula for the Chirp waveform. Now the equation is like this one. Now A is the unit amplitude, and pi is 3.14, and K is the final frequency minus initial frequency in terms of hertz, and in the defined finite of time period in terms of second. Now just give an example. I want to create a Chirp waveform. The Chirp waveform will increase from 0 hertz to 18 hertz within 20 seconds. Now, the formula should be the sine, and then because 18 minus 0 divided by 20 is 0.9, so that means that the 0.9 pi times x, and that is a square, like a square, all right? So let us do it in the clamp fit. Have some fun, okay? Now go to here. I close everything first. Now what you need to do is that, again, go to, basically I repeat one more time, okay? Analysis, create the data, go to linear first. Now again, I want to create 20 seconds. That means I put 20, 100, 1,000, and 1, and hit OK. Now, for the column B, I go to the create data. Now, here's the key. Now, at this point, I want to give, for example, 20 millivolt. I put this sign here. Now, remember that I told you that I need to put the formula here, and that this one will be 0.9, and pi times x with the square. Square is the shift 6 and 2. All right, then I hit OK. And then I copy this one, paste this here, column C, paste to column D. Then I save it. We can say Chirp today. All right, Chirp wait. And this will be in the ATF format. Hit OK, yes. Then I close all. Then I open it. Remember that this Chirp wait today. Oh, click here. Wow, is it beautiful? I think so. It's 20 millivolt. Now you can, this is the last two. You can use the cursor to measure the time, this speed to this speed. That, 0.055 should be about 18 hertz. Should be about 18 hertz, right? So again, you don't see the unit here, so you need to save as. Okay. Save as Chirp wave today. Now you need to save an ABF format. Hit OK. Now you can go to the edit, modify signal parameter. You can put minimal here. Now you can see the minimal here. Now you can go back to the Clampex, go to Edit Protocol, Waveform tab, check this stimuli file, click here. Now you can see the Chirp wave, ABF format, and hit OK. Now make sure that the duration is correct, 20 seconds, and update preview. You see, is it beautiful? Yes. Right. All right. So let me get back here. The time's almost done. Now, I have shown you how to create a customized waveform can be created, in Clampex using the user list and stimuli file. So my conclusion is that the more you know pCLAMP, the more you like it, the more value you get out from it. So I would like to thank you. This is my thank you slides. I want to thank you, Sunny Tan, to help me out to create the formula for the sine wave and also for the Chirp wave. You remember that the two formula, right? He is a college student at UCLA in engineering, major in engineering department. And I also thank you to all of you of our loyal Axon user, and also thank you to the Axon team of Epoch devices.
We thank you for your attention, and we look forward to speaking to you again.